Welcome to my channel. Today I'll be discussing Border Gateway Protocol or BGP, the routing protocol that literally holds the internet together. In the next 5 minutes, we'll explore what BGP is, why it's critical, how it works, and the challenges it presents. What is BGP? BGP is the standardized exterior gateway protocol designed to exchange routing information between autonomous systems on the internet. Think of it as a postal system of the internet. It determines the best path for data to travel between different networks worldwide. Unlike interior protocols like OSPF or eIGRP that work within a single organization's network, BGP operates between different organizations, ISPs, and countries. It's defined in RFC 4271 and is currently in version 4. Why BGP matters? BGP is absolutely mission critical because it routes traffic between over 70,000 autonomous systems worldwide, enables policy-based routing decisions, not just shortest path, provides redundancy and failover capabilities, allows organizations to control how their traffic flows, makes multi-homing possible for enterprises. Without BGP, there would be no internet as we know it. Every time you access a website hosted by a different provider, BGP is working behind the scenes. How BGP works? BGP operates on several key principles. BGP is a path vector protocol. Unlike distance vector protocols, BGP maintains the complete path information to prevent loops. Each route advertisement includes the full AS path. It's TCP based. BGP uses TCP port 179, making it reliable and connection-oriented. This is unusual for routing protocols but essential for stability. There are two main types of BGP, eBGP and iBGP. eBGP is external BGP between different autonomous systems. These peers directly exchange routes and increment the AS path, providing natural loop prevention. iBGP is internal BGP within the same AS. Here's the crucial point. iBGP speakers do not modify the AS path, and they follow the split horizon rule. Routes learned from one iBGP peer are not advertised to other iBGP peers. This prevents loops but requires either full mesh iBGP or route reflectors. BGP uses path attributes to make routing decisions and control propagation. Categories of BGP attributes. We have the well-known mandatory. These are always present and always propagated. Under this, we have AS path, next hop, and origin. There are also well-known discretionary attributes. These are recognized by all BGP speakers, but it's not always present in the advertisement, like local preference and atomic aggregate attribute. Another is optional transitive attributes. These are propagated even if not understood. Under this, we have the community and aggregator. The last category is the optional non-transitive. These are stripped if not understood. Examples of which are multi-exit discriminator and originator ID. Attributes can be classified further as transitive and non-transitive. Transitive refers to attributes transferred to one AS to another without alteration, while non-transitive are passed only to the next hop router. BGP has an extensive best path selection process. It uses these attributes in order, starting with the highest weight for Cisco routers, then going to the highest local preference, local routes, shortest AS path, lowest origin type, lowest MED, eBGP over iBGP preference, lowest IGP metric to next hop, oldest path, lowest router ID, lowest neighbor address. How does BGP prevent loops? It uses AS path attribute for eBGP routers to reject routes containing their own AS. iBGP has split horizon mechanism to prevent re-advertising between iBGP peers. For topologies with route reflectors, originator ID is used. Today's internet runs on approximately 900,000 BGP routes in the global routing table. The protocol continues evolving with enhancements like MPBGP to cater IPv6 and VPNs. Despite its age and limitations, BGP remains the backbone of internet routing because it scales globally and provides the policy flexibility that the internet requires. And that's a wrap on BGP. If this video on Internet's backbone helped clarify how routing really works, smash that like button and subscribe for more network engineering content. Thanks for watching. I'll see you in the next one.